Welcome to the DiscoBots first online session of the season. We're going to be doing this every week on Sundays, and we will try to record them every week. But for now, if you can't make it, then we'll record it. But if you can make it, you're going to get a lot of more interaction if you can attend these and ask questions and get involved, and we'll try to get you people out tasks so everyone's aware of what needs to be done the rest of the week. Our meeting in person schedule is going to be at Lamar Tuesday, Thursdays, and then Saturday is our big meeting where everyone comes together. I think we're starting at 10, but I think day to day we might start a little earlier depending on what the schedules are. And then I think generally we go from 10 to 3 on Saturdays. And then Sundays we will have this meeting around this time, around 5, 6, I guess it's 6 o'clock Sundays every week up until March. So try to be involved as you can. These first few weeks are going to be very fast in terms of decisions and process. So if you are not as available, but you can follow what's on Slack and what's on these YouTubes, you're going to keep up with a lot of these decisions. And if you miss out, please just send us a message or send me a message. I'll be happy to fill you guys in. Other schools we have involved is Westside is going to be doing Tuesday meetings, possibly other schedule on a Wednesday, but that hasn't been confirmed. And then obviously Westside people also go on Saturdays to Lamar. And then Carnegie has a meeting schedule that they already do robotics on for VEX. There are going to be a few people there doing FRC at the same time. So if you are at Carnegie, send me a message and we can make sure you're plugged in. I'd like to have kind of a dedicated FRC meeting at Carnegie for people that are interested. And then, yeah, that's our overall schedule. And then we'll let Cedric here, who's kind of leading the whole CAD design process for the team, kick off his presentation, and we'll go into the robot design.
Okay. So we already discussed this during kickoff, but obviously this year our main goal is to go simple, right? Well, someone's trying to go in. Our main goal this year is to make our robot as simple as possible. And we already discussed kind of that we probably knew in order to get L2 to an L3, we were probably going to need an elevator. So this is that. And for the sake of simplicity, I thought doing a 2-stage elevator would be too much. So right now, it's just a standard 1-stage elevator with this mechanism on it. And so the whole idea with this robot is that we can...
Hold on one second. I'm looking at the screen. Do you guys have the CAD as your main screen?
I can change myself.
Yeah.
Okay.
Are you not seeing CAD?
Okay, now I got it.
Okay.
Sorry, I'll take a pause there. Got it.
So the whole idea here is we can intake it very easily through the human load station here, and without manipulating the coral in any way, like this, without manipulating the coral in any way, we can outtake it and it's already in the correct orientation to score on the reef. So the whole idea here is the elevator would be down and someone would roll the coral into here, and we would have some sort of flywheel mechanism, or we were also thinking like vector mecanum wheels to drive the coral out of this and onto the reef. You'll notice here, actually here, I'll talk about this section first. So this whole idea came from one of the Casino Clash Catathon, this one most innovative. And I thought one of their elevator was extremely simple, and I feel like it's something that we can do. So yes, this is a lot of stuff, I know, but their whole elevator is just this. If you look down here, it's just 2 motors connected to gears. You have sprockets on both sides, and then basically the same setup up at the top with the main carriage here, with this main carriage, and you have these little brackets to mount the carriage to the chain. And I feel like that's, I know we said we wanted to stay away from elevators as much as we can, but as far as elevators go, this is probably one of the simplest versions we could do out there. So that's why we did that. We decided to say a very hard no to anything more than one stage, because when that happens, you start to mess around with tension, and that's just not something we want to do. So we thought this would be enough. Yes, there's a lot of interference right now, but we'll clean up the geometry in a sec, and when we finalize our approach. Now, for the algae mechanism, you may recognize this. This is from the 2014 robot for DiscoBots, Octanus. It's just this. This is what we plan to do. So a lot of our plans, there was a 4-bar involved, but we thought this was the simplest way to do this. And how this would work is essentially this would just pivot down. This would pivot down and intake the algae ball, and then you would get to the ball into a position something like this. And when you get to the processor, you can just outtake it, and the ball should go straight into the processor. So we thought that was probably the easiest way to do that. In terms of climb, I know we discussed that, it's not a priority, and it isn't. The only way I see us doing climb is some RA3D teams are prioritizing climb. So if any of them have a good system that we can implement without making huge design sacrifices, that's feasible. Or when every bot gets released, they usually have a climber as well. So that's always an option. One thing I would like to point out is that a lot of our ideas did align with a lot of the ideas like that were from other RA3D teams. I saw Penn State RA3D had a very similar approach, doing L1, 2, and 3, and doing algae. This is Cranberry Alarm. They actually have quite the complex robot for an RA3D. They have a 2-stage elevator. And you can see here, we kind of have that same idea. Of course, we're going to iterate upon our idea more, but this should be a good general idea of what we're trying to do, elevator-wise. Yeah, that's sort of what I've been working on. There was another one of our ideas. Before I got to this, I was thinking, how could we do this without an elevator? And that's when I stumbled upon trying to do a 4-bar, which looks something like this. This was the old version of the funnel, we can call it. It works in the same way, in essence, by the human load getting dropped into here, and then the coral getting seated here, and then you can outtake it through this hole onto the reef. But after some looking at this, oh, by the way, this inspiration was from Spectrum 2015. I saw one of their videos was a prototype 4-bar, which is where this whole idea came from. And basically what they had was they used I think 2 motors, but only one thing was actually being driven, which is this this piece of tube stock right here. And you can see via all the connections, you can get high and you can get pretty low as well. So I thought this because before I figured out to get the right elevator stuff, I was struggling to get the right reach to get to L3 using the elevator. So I thought this could have been the alternative. But once I looked at it again, I saw this is a lot of metal and it's really heavy. You could do a chain bar, which has the same functionality but works slightly differently. But I decided that this may be not the best option, and it may just be better to do a elevator sort of like this. Yeah, that's what I've been working on this past day, basically. Yeah.
I think it's a good start. I'm not so worried about the lifting mechanism.
Yeah.
I think if you've done the math and it goes, that purple, the top purple is max height.
Top here from here to bottom is 41.75, which is extremely close. Again, that's definitely something I'm going to have to refine. But yeah, you'll see this is parallel distances, 41.75. The max height is 42, so we have a quarter-inch tolerance. But I promise this will get fixed. It's going to be a shorter elevator, and we're going to change the geometry of this blue plate here to make this work the same way, but be a little bit shorter.
And this goes to L3.
Yeah, this is able to go to L3.
Like, what's the tolerance? Like, it goes above L3? Or?
Slightly above. I realized that for each of the reefs, the dimensions they give you, you could kind of do like 1.5 inches, 2 inch above or below, and it should still get onto the reef. But right here, we are at absolute max reach. This number is 48.3, so we're like right there. Yeah, the tolerances aren't great right now, but that's because this is rushed. But I think we could make it better if I spent more time trying to refine all of this.
Oh, I have a question. So for the algae mechanism, does it gonna like squeeze the ball over it, or it just like kind of like just extend it and grab it?
It's gonna work like this. This is 2014, and it'll work in a way where the arm just kind of pivots down, and it intakes the ball and seats it right there.
Oh,
and
okay.
That's why I have the little triangle thing here. That was the idea behind that. Yeah.
Okay, gotcha.
And then also, based on Cranberry Alarm's demos, we saw that it's actually not insanely difficult to de-algify the reef. What they had was just an axle with compliant wheels, and as long as you hit the bottom of the algae balls, they came off pretty easily. So my idea was to this is pretty late edition, so I didn't really get to CAD it all. But my idea was to have a set of roller shafts, basically, right in this region that's on the intake, I guess you could say. And it should just push the algae balls out where this mechanism can control it and score it in the processor. Yeah. Oh, this is also a 29. This is a 29 by 29 drivetrain, because I figured out that there really isn't any choke points this year, especially compared to years past. So having a bigger drivetrain isn't really a bad thing. If anything, it may be a good thing, because I suspect a lot of the robots this year are going to be pretty tall. So having a larger drivetrain would also help with stability and weight. So, yeah. That was my 2 cents on it. Tried to max it out without getting too close.
How much tolerance?
So a 29 would be 29 times 4, which is 116. The max is 120. So, yeah. But if we cut, 29 is a pretty solid number, so hopefully we don't have any issues cutting 29-inch tube stock. So we should be fine in that regard. Go ahead, Les.
Surely. Smaller, right? The corners are going to be...
Yeah. Yeah. Go ahead, Les.
Yeah, it is nice.
Oh, Les, you're muted, by the way, Les.
Okay, better now. Okay, yes. So the question I had was the ball intake. I noticed on Cranberry Alliance, they have like 13-inch 1x2s, and they have compliant wheels on top and bottom. And they actually don't put it inside the robot. They just go out there and hold on to it. In a way, having the robot clear might be good, and not having a ball stuck in the robot too. So it might actually help, make everything a little bit thinner too. if you could just still lean it forward, and they basically you could spin them opposite direction to pull the ball in, and they were saying when you go out, you could spin it kind of the same way. It's kind of like a conveyor belt, and it goes in. Off of that. I don't know if you saw that, but so yeah. I mean, it would allow you to have this part in the middle clear. The other thing, we've got a lift, we could probably lift ourselves. I mean, I don't know how heavy the robot is, but if we geared it, pretty decently.
Yeah, I mean, my idea for the lift was to make it just so strong that even if we, at the end of the day, if we actually decide to implement a lift mechanism, we shouldn't have to worry about, is it strong enough? I want to make sure that when we build this lift, it's going to be strong enough for that.
Yeah.
That was my.
Yeah. The other thing is, ThriftyBot lift is not a bad lift to do. They have a single stage, and it's all out of the box or whatever. It's pretty reasonable. So I don't know.
Yeah, I was also considering that. I remember looking at that a while ago.
If we get it.
It's an option. Yeah,
it looks like, knock on wood, it doesn't say it's out of stock yet. So if we
don't worry about stock.
Don't worry about that.
Options, and then whatever we can actually order, then you can go deeper into, okay, we can use this as our part.
Yeah.
Most of the elevators we've made, I don't think we've used any kit, so we probably the equipment.
Yeah, yeah.
I thought in 2019 you guys had a lift. How did that work out? Was that a challenge?
Oh, that was the
hatch panels, I think.
Patch. Our lift was a little heavy. Like our taking the balls in was a little bit heavy, so I don't think it was all that successful. But
okay.
I don't know. I mean, it worked okay. We did it, but
it's not that different from the design you just showed.
Right.
I mean, first chain all the way up. It's not that. As long as you don't multi-stage lifts, which we've not really done that much.
It should be fine.
Yeah, it's really not.
It's doable.
Especially now motors are getting so much stronger.
Yeah.
I guess we did it with Falcons, maybe 2 Falcons.
Yeah, I think we just used Sims or something. It was 2019, so. But anyway, I think that our issue though was we had a ball and a hatch mechanism, which made it too heavy. So this not bad. I mean, the other thing on your mechanism, I see you have it sideways. Cranberry Alliance has one that it's more like with compliant wheels, it just wheels in, but it requires the human loader to use those kind of those rails to go straight. So you have to, then they have some kind of a funnel type thing, but
yeah.
So
their design also, their design requires you to outtake the coil, half of the coil out of the robot before you can move the lift, and I thought that was, I thought that was not very good, so I decided to stray away from that. So, yeah.
Oh, yeah.
Yeah, it's pretty simple. I like the simplicity. I mean, I don't think we need to aim for L4. I think climber, we can keep some flexibility on things, but it doesn't have to be integrated to this. I almost like just making really efficient systems that'll do what they need to do, and then if we have time for a climber, okay, we can look at it. But I just, after reading a lot of strategy things, people that speak about climbers, they all talk about deep climb.
Yeah.
Just have a range of design.
Yeah, I saw a lot of the RA3D teams, like Cranberry Alarm, Penn State. A lot of them just went straight to, we need to do the deep climb, which I don't know why they did that.
I think it's a function of they're assuming their partners will not be able to climb.
Yeah.
That's our experience. I mean, it's like,
small district events. So there's
Mhm.
a pretty high likelihood that even if your partner can climb, it might not work all the time.
Yeah.
So you're really hoping that you are the climb and the other person's just a part.
Yeah.
So yeah, I think given
Yeah.
the park capability and number of people we have this year, I just don't know if that's in our cards. I think we need to focus on.
But actually, if you have this lift here and you keep the middle open, it allows us some more options, because basically we could just somehow grab on and go straight down versus just have a donut hole in the middle and just kind of lift up. But
That's an interesting idea, Les, is that we could have like a version that's like a really simple output, and then we could have a more complicated one that has space for the cage to go in.
yeah, so if you don't have the blue thing in there, you could have a donut hole in the bottom. So basically, just
yeah, that's true.
Yeah, so you could basically have two versions of your intake mechanism. One that's more fancy that could allow the cage to go in, and it probably will take a lot more design to make sure it fits and locks into the lift. And then the other one is just you won't be able to get the cage in there. So right, I mean, we obviously could build the first one as a prototype, and then eventually have like a version 2 that, if we make the lift strong enough, to bring in the whole cage, and then we just go up. Even if it's a shallow climb, I think we could go up pretty easily.
yeah, it's like 8 inches for the cage, so 8 by 8.
The deep is more tricky because then you're really having to deal with like CG, and would we probably go up a lot, but like would we actually touching the ground?
Hang or not.
Yeah, that's a I think that's
So
just such a hard challenge.
yeah, it is. Yeah.
We could definitely make this type of design, probably do the shallow, which would be interesting.
And to your point earlier, Cedric, about your footprint size, the size of the drive base, if you maximize that, obviously that's going to give you more room on the inside to have that 8 by 8 square fit inside.
Yeah.
Yeah.
And you do kind of have weight on the back and weight on the front. So, even if you were to put the algae thing down in the back to kind of help balance things.
Yeah, so that's true.
Keep it more, in the center. Yeah.
Yeah.
So
I'll think about that. That's a cool idea.
2014 robot that you refer to, Octanus, it used pneumatics to lift or to lower that arm. You can see the cylinders.
Yeah.
My vote would be to avoid pneumatics.
Yeah, no, I agree. That's not really something I personally have ever dealt with, and I don't want it to stay that way for this year. I would advocate for just using like something like a Neo probably, and either do a chain and sprocket, or we can try to do a rack and pinion sort of thing, or just have 2 gears and just have it pivot. It's something I have to look at, but yeah, definitely no pneumatics. I want to stay away from that.
Yeah, there's also just swap in topics. So get that option.
Yeah, it's not that heavy, so you could just deploy and come back. So an upright and a leaning, it's not bad.
But other than that, I think this is pretty good start. I'll think with this general direction. I don't have any issues with it.
I'm pretty sure.
Dimensions. So just make sure you make sure you have enough tolerance, because if a single stage lift can't get up there, then it's a little concerning for L3.
Yeah, definitely.
We need to think carefully about what we're doing.
Yeah.
Anybody else have some thoughts or questions? I know we got a lot of new people here. Maybe they haven't gone through this before. It's okay to ask questions of what this is, how this is going to work, because this is a very basic CAD.
I just wanted to throw out one general comment. Cedric, you mentioned you were concerned about the 4-bar that you were talking about earlier from
Yes.
Spectrum, and you're concerned about the weight of the mechanism. Obviously, you can change that design. I mean, you don't necessarily have to make it out of tube. You can make it out of Lexan sheet. So
Yeah.
just flat bar linkages. So don't immediately rule that out. Just keep that in your back pocket if you want to investigate an alternative design as opposed to the elevator.
Yeah, that's a good point.
In the past, we would always take a 4-bar over a lift.
An elevator, yeah.
And that is still true for like Vex. It's just so much simpler to build one quickly, and so that just generally holds for robotics. So I wouldn't totally ignore it. I mean, it's worth looking at the path on it. But one issue I see with it is we're not going very low. And typically a 4-bar is picking up something from the ground.
Yeah.
Nice and flat off the ground and keeps it completely parallel to the ground as it goes up. And that's where it's a huge advantage to like take an object off the ground and lift it up pretty high. In this case, we have a little bit of flexibility, and I don't think we're not even going that low, so it's not even like we've drawn at a very long 4-bar. So I don't know how much height we're really gonna get out of it.
It's true. Is this one? This like barely gets to L3. It's about the same as the elevator. So yeah. Greg pointed out a good reason earlier. If you want to switch from L2 to L3, you'd have to change the distance. You need to like drive away from it as this gets into the center. Oh, because as you trace, if you trace like the middle of the circle, it basically draws an arc, and it's not a straight line, which would make it harder to score in theory.
Yeah, it almost seems like the way you build this, you need to make the outtake be almost a little offset from the center, because you want it to go like almost to the very edge of your frame perimeter when it outtakes, so it's as close as possible.
Yeah.
So it's going to look a little funny when it actually is built.
And
also, I'm not sure.
To that effect, you're obviously not going to have room for your algae intake mechanism, because obviously that's a packaging issue there.
Yeah, definitely.
Yeah. I'm not sure how like easily the PVC will sit inside the funnel. So like once it like how consistent we can get it to the right orientation. Like we should probably need to look into it and test that a bit more before we settle on a design for the funnel. I'm not sure how like I know Cranberry Alarm showed some designs for something like that, but I also know that like pipes try to get into orientations that they get really stuck easily on funnels like this. So yeah, I don't know if we need if we can do it fully passively for the funnel, or we need wheels to push it in a certain direction. Like push it down or something.
So the other thing about the wheels, you were saying, Cedric, that to get the algae off, you would use a wheel to kind of, so you'd have compliant wheels spinning.
Yeah.
And in contact with the algae, and it would kind of either spin it up or spin it down. So, if you actually if you did an active coral, I don't know, it might actually, you could spin it to get the algae off too. So
yeah,
I don't know. Yeah,
it's definitely an option.
Yeah. So, I mean, if you have it active, you could use both, possibly.
Yeah, you could.
Obviously, it'd be heavier, but the good news is the element's not that heavy. The coral's not that heavy.
Yeah.
And I think what Chris says about maybe not using aluminum or something is we could do something that's a little bit lighter.
Yeah, we don't have to use box tube for a lot of this.
Yeah.
So.
Yeah. We could do aluminum plate with or something. Yeah.
Yeah, we definitely could. Okay.
Well, it doesn't sound like we have a lot of dissent, which is unusual for our group.
It is.
I don't. That's really concerning, though. The fact that no one is saying no to this idea is really concerning.
I would say in the past we have a lot of priorities, a lot of things that we want to do, and we're usually trying to do kind of an L4 sort of design.
Yeah.
If you do that, it adds a bunch of different variables of how you could do it and complexity, and so that's why we generally have less agreement, because some designs are very complex. It takes more time, but in this case, we're just not aiming for the very max, so it's not as complicated of a design, and everyone can generally agree this should work if we get into the details. So I don't have any major issues here. I think we're keeping it simple, something that we can build with our resources and time, which is something we kind of made some mistakes last year. So I think we need to really simplify a little bit and try to build faster and be sure it works.
Yeah, and we could, the intake of the algae prototype, we could probably do that at some max pattern stuff or whatever. We could do something.
I saw Cranberry Alarm, they have just like two extremely long tubes of max pattern, and then they just have wheels just going across it, varying compressions, so they can test really quickly without having to swap anything.
Yeah, and we do have some at Lamar. I think we have like a 25-inch whatever. We could do that, and actually you could even do the pivot with that max. What are that things
max
called?
Spline.
Max Spline. Yeah. Right.
Yeah, I was thinking about what you were saying, Wes. I think we do want the ball to go where we can fit inside a frame perimeter when we have the algae, because of autonomous. I think you have to start within your frame perimeter, right?
So I don't think we have I think basically we have one coral, but we don't have a. We would have to knock the either knock the algae off, or if it's the right height, we could go capture the algae. And maybe it's possible, if it's upright, we could capture it and then put it in.
Oh, I see.
Yeah. So if it's on that, we might be able to keep it inside perimeter and then have the wheels on top and bottom just kind of suck it in.
That's my comment. For some reason, I thought that there's a world where you can start with the algae. So, no worries.
Yeah. Yeah. And we are going to have to figure out how to get rid of the algae on the reef, because we can't score level 2, I guess. Unless we get rid of something. So.
I saw. Yeah. Go ahead.
I think that's something we can easily play with in CAD. Just appendages that stick up as the lift goes up to knock the ball up. So.
That's true. You can even make it something that drops down and then just knocks it up. Yeah. And the lift is going to go up and down. So we've got motion. Yeah.
I think you could actually split up the sides. So like, let's say you have your coral deposit side, and then on the other side of the lift, you could have weird, appendages that come out that are specifically designed to quickly
knock the algae out.
Oh, okay, yeah.
So you would hit it from whatever side you're trying to do the action, so that way it's very quick. I
would do that, but I remember they also Cranberry Alarm also made a video on de-algifying, and they showed that if you hit it like from the side of the algae, it actually makes it like more snugly fit. And they said that the best way to do it was to either hit below or above. Well, you're supposed to contact the algae ball below to pop it out of the reef spot. Because if you hit it from the side, from what they saw, you were just hitting the ball up, which made it more wedged in between and would make it harder to remove eventually.
Yeah, unfortunately, this is one of those things that we don't have a great testing apparatus. It's like we don't have a full reef to quickly like check all this out, so we can do some math in CAD and probably start looking at what people are prototyping and kind of base it off of those sketches because it's going to be difficult to do. I'm okay with this direction, Cedric. The big decision is go deeper into on-shape. I think you go deep into the drivetrain on-shape.
Yeah.
Pretty fast and start thinking about how you're going to do the main lift attachment to the drivetrain and think about like how stable it's all going to be. And then once everyone's happy with that, then you can really start working into the details of how to actually make the motors.
Yeah.
What mechanism.
Yeah, I was going to mention, you might want to also consider your bumper height too, as far as, picking up the algae. Do you want the bumper height high, low? That type of one extreme versus the other.
Yeah. And for algae, we would want it to be low. I think it would be the easier way to do it low. But I'll have a, yeah.
Yeah, obviously it'd be easier to pick it up if it's low, but then if you're trying to go to the processing station and the processing station is 7 inches up, then, you don't want to have to fight to get it up into it.
Yeah.
So maybe,
We'll have a look at it.
Yeah.
Yeah.
Concerns.
I guess while we're at it with bumpers, they made like a lot of rule changes, but should we just keep doing bumpers the way we do them? Just wood and then foam. Like they made it so you could have more padding and you have more materials, but can we just do it the way we normally do it? I think it would be the easiest way. And then
we need to make a little improvement over last year's bumpers. They were
definitely
not that great. We've had much better bumpers in the past, so we need to just look carefully at the attachment and make sure it's well thought out. We just didn't do a good job of CADing that last year.
Yeah. Attachment. I'm thinking I want to do the latches I did for Catathon. I want to see if we need to order those to see if they actually work or not, but they should.
We have a number of different latch attachments. Bumpers to show it to you, but I think you need to just go ahead and start with drivetrain.
Yes.
Lift structure, and then you can start thinking about your attachments, the bumpers, based off of those structures, because you're going to need to, those need to take first priority on position, and then the attachments can be around those.
Yeah.
But for just, prototyping, I would say, just go ahead and assume that it's going to be a 5-inch tall bumper using 2 pool noodles, unless, some other teams indicate that there might be an advantage to using a different construction type. But obviously, if we're going to try to keep it simple, then keep it to what we're familiar with, which is the pool noodles.
Yeah, definitely.